Okay, so let us see some of the different interfacing and then we'll call it a day. Just now we have seen output. Now we are combining input and also output. Want you to try to study this and try to see how this connection affects, because in test 2 you need to draw. So here we are using port C. But out of port C, only 4 pins of port C are connected to LEDs, right? Which is this one, this one, this one, and this one. What is port? This is RB, so it is port B, pin number 0. It's connected to input or output? Input. So this one you need to configure as input. Is that okay? Whenever you deal with chapter 7, you need to configure input and outputs. Definitely you need to do that in your test 2 also. So now before we go to the programming part, so we need to understand this is the switch connection. When the switch is not pressed, what is the logic here? What is the logic here? 0. Why 0? No voltage supply. It is 1. Do you see there is 5 volt here? And you go through 1 kilo ohm. It's connected here. When you're measuring the voltage drop across here, what you're getting? You're actually getting 1. It is 1. Basically, the voltage drop here is equivalent to the voltage drop here, right? Because this is open circuit. So when you 1K, why do we choose 1K? Because this will give the maximum current draw here. V equals to IR. When R is high, then I also will be high and V also will be high. But you won't get 5 volt, you'll get 4.96. That's why whenever you do in a measurement, lab measurement and things like that, you'll never get 5. You get 4.96. Ever we ask why? And going through resistance, a certain energy is released as heat. So you lose certain energy, certain power there. Anyway, this one, the switch is not pressed, it is logic. This is logic 1. When you press the switch, what happens? It gets shorts to ground, right? All the current goes to ground and therefore it becomes 0. So take note, when it's not pressed, it is 1. When it's pressed, 0. This is important. So you need to analyze the circuit. If you do something like this, not gate, then not pressed, you give 0. Pressed, you get 1. So you need to see the circuit and then understand. Is that okay? Next, this one, the first one, to turn on, you need to give logic what? This one, pin 0. What logic you need to supply to turn it on? Logic 1. Pin 2. Okay, pin 2 is what we know as the sink in current. Do you see that there's a 5 volt voltage passing through 1K and going through the LED, and the anode is, the cathode is connected to the pin. So here is high voltage, so here must be 0. This is what we call as sink in. The current flows to the microcontroller. So sink in. And PIC 18 has a very high level of sink in current. It can accept very high level of sink in current. And this method is much more better because it doesn't use much of the microcontroller's power. Basically, you're just allowing the external 5-volt current to just flow through. This one, you're supplying the 1 volt. So sinking current is much more better. But look at the schematic. So if you want to turn on this LED, you need to give logic 0. How about the next one? If you want to turn on, what logic should you give? You should give logic 1. NOT gate will make it 0, right? So it will make forward bias. How about this one? You need to give 0. Because of the NOT gate will convert it into 1 and then it will turn on the LED. So these are all the different possible combination of interfacing that you can have. So you need to look at the schematic and then decide, okay, to turn on